Hey everybody, welcome to another episode of Ruby Rogues. I am David Kimura, and today on our panel we have Eric Berry.
Hey everyone.
Andrew Mason.
Good morning.
And we have a special guest with us today, Sean Handley.
Hey, how you doing?
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
So Sean, can you tell us a bit about yourself, who you are, why you're famous, and just some of the things that you're doing nowadays?
Sure. So I'm based in Manchester here in the UK. I've been working with Ruby for about 10 years. Currently, I'm on the back-end team for a delivery company called Stuart. So we operate over here in Europe. And I do quite a bit of blogging, I guess I would say. So I do quite a lot of blogging on our company blog and also on my own Medium account because I like learning, and I kind of find that blogging about things is a really good way to help the knowledge stick. So I did a piece recently about how you write Ruby bindings, particularly how you might do that using FFI, and that got picked up by Ruby Weekly. So I guess that's me in a nutshell.
Great. And for those listening, can you explain what a Ruby binding is and why you would use it over the traditional, just plain old Ruby objects?
Sure. Okay. So in standard Ruby, all the code that you write is executed by the Ruby interpreter and sort of within its own separate runtime. That's really good for most general purpose programming. And Ruby's lovely and expressive and clean, and it's a good language in which to express your business logic and your high level concepts. But like other high level programming languages, Ruby isn't the best choice if you're doing anything that could be considered machine intensive, like raw calculations or something that needs to be optimized for the hardware that you're on or anything like that. Since Ruby's so high level, it kind of protects you from all of the access to the lower level machine. So if you ever want to do anything that's more involved, then using bindings is kind of a good way to have the best of both worlds, where you use a lower level language to produce a binary that will run natively on the machine. And then using the binding, you can tell it to do stuff for you. And that way you still get to have all the nice high level construct stuff with Ruby, but you also get to take advantage of being able to talk to the machine directly.
And so one of the biggest benefits that you would notice with something like that, of course, would be the speed. So the speed in which a normal Ruby method would execute would not really compare to something like with a Ruby binding or a C extension, something like that. Is there any other advantages other than speed that one should be aware of if trying to use a Ruby binding?
Well, for us, actually, what got us into this path of exploring how we're going to use Ruby bindings, because this was related to a project that we actually used over at Stuart. We wanted to use this awesome library that we found that was written by the guys over at Uber, and it's called H3. So H3 is like a way of indexing space using hexagons. So it recursively divides the surface of the Earth into individual hexagons down to like the square meter level. We wanted to use this in our tool set because we have a data team who monitor sort of supply and demand when people are requesting deliveries, various events happening in real time. So this library looked awesome, but it was written in C, and our backend tooling is all written in Ruby. In writing like a binding into this C library, suddenly we sort of opened up a new possibility for ourselves in that there were no Ruby tools that could do H3, but we could build one ourselves using a binding, and suddenly H3 works in Ruby. So using a binding isn't necessarily just about speed. It can be about opening up your access to other projects.
Earlier, you mentioned FFI. Can you tell us what that is and give us a little background about that?
Sure, I'd love to. So typically most people, when they think about bindings, they think about native extensions. So in C Ruby, which is the Matt's Ruby interpreter, you can write native extensions effectively in C using an API provided by Ruby itself. This lets you do all the same low-level things that you'd be able to do in any other low-level language because you have sort of a lower level of access to things. But it has some limitations in that it will only work for C Ruby. So if you're running like a different Ruby interpreter, then native extensions aren't going to be for you. Also, FFI has the additional advantage in that you don't actually need to compile anything to work with it because FFI is based on something called libFFI, which is a C library. The intention is that it allows you to access pre-compiled binaries. So say I write a program and I compile it as like a shared binary. If I was going to wrap that up into a C program, then I would make references to it, and then the C linker would reach into that and figure out where all the functions were that you needed to, and it would link everything together, and then it would get loaded into memory. You don't have that option with Ruby because Ruby is an interpreted language. So you don't get to do that at compile time. You have to do it dynamically at runtime. And libFFI is designed to let high-level interpreters access pre-compiled code sort of on the fly, if you will. So FFI has that additional advantage in that you can just reach into anything that's on your system and has already been compiled. And as long as you know what the function name is, what parameters it takes, what you expect the return type to be, then in theory it should just work. And if you use something like the FFI Ruby gem, which wraps up all of this, you get a really nice, clean domain-specific language where you say, okay, here's where I expect this shared library to be on disk. And then within it, I expect there to be a function, and it's called this. I expect it to take these arguments, which have these types. And then I expect it to return something that is of this type. And then you get this nice, simple one-liner, and it's all super easy to work with. And also, if you do anything that requires memory management, then FFI, the gem FFI has this sort of automatic memory management built into it. So you can build your own buffer using a Ruby DSL. You can do things with that. That gets put through to your low-level binary. And then later on within Ruby, if that falls out of scope, that Ruby object falls out of scope, then behind the scenes, it's going to clean up the memory lower down for you. So you don't have to worry about mallocing and freeing in the same sort of way.
Yeah. And so if you were not going to use a already compiled source like the H3, if you're going to use something else, is there any recommendations that you would have on how to organize the code? Because I think that a lot of times the FFI library also provides other abilities to refactor your own code in order to increase the execution speed of certain calculating functions.
I'm sorry, David. I didn't understand the question. Can you repeat that?
Yeah. So, is there any recommendations that you would have for organizing code so that it would be easier to use a FFI library like a C extension or Go extension in your projects?
So how you might organize your own Ruby code, for instance?
Correct. Yeah.
To be honest, I guess what you'd probably want to do is create your own namespace that referred to whatever external library that you were going to be calling. So you could create, in our case, we created a Ruby gem and it was in the H3 module namespace. And then we wrapped up all of our functions within that. And then anything that includes the H3 Ruby gem can just say, okay, I'm going to do H3 dot whatever the method name is, and it just works. So I guess you'd probably want to sort of isolate it in that regard rather than sort of pepper it throughout your code base. I'm sorry, is that what you were getting at, or have I missed the point?
Yeah, and I'll just add on to that with when working with a library, this is one reason why I think it's good to have your code organized, because you're going to be able to then extract out certain calculations that you're running much easier. Whereas if you are not following a law of Demeter where you are referencing active record models within certain calculations instead of just taking in an array of integers or something like that, then that's going to be much harder to refactor out, because now you have not only your function that is performing the calculation, but it's also relying on some other information, like a connection to your database and stuff.
Mm.
So having service objects that are extracted out where you're able to just focus on the numbers and not so much the objects, the active record objects or the models, then that's going to make it a lot easier to use a C extension or something like that within your project.
Yeah, that's totally right. No, I see. I see what you're saying now, actually. So yeah, if your code is sort of clean and nicely separated, then yeah, it becomes a lot easier to sort of dial into external libraries. So with the H3 library, actually, they make you initialize all your own memory and then pass that into the functions. A lot of C code where you'll give it some arguments and then it will do some stuff with memory itself, and then you'll kind of be given something back that you're expected to memory manage yourself. But yeah, when we were integrating with that, they made you sort of do all of that up front. So it's kind of like dependency injection with the blob of memory that you want to put in there. So yeah, that's definitely something you want. You want sort of isolated functionality, and then it's really easy to hook in where you need to.
Yep.
On our discussion points, I'm not sure who wrote it, but this said connecting Ruby to binaries written using safer languages like Go and Rust. So why are Go and Rust safer than Ruby? I mean, we all know that we can easily shoot ourselves in the foot with Ruby, but do you mean safer in the sense that they're typed, or?
Yeah, I wrote that in our notes. So I'm sorry, I didn't fully expand on that point. When I say safer, I think I mean safer than C. So I really enjoyed playing around with native extensions and FFI and C and so on, but I still managed to get seg faults and I still managed to get memory leaks, and it was a great learning experience. But it makes me feel slightly cautious if I want to write something in C and then roll that out into production on a Rails application, for instance. I'm just thinking, is this actually going to kill processors left, right, and center? So when I say safer, I mean that when you compile down to a shared binary on disk, you can use C to compile that shared binary, or you can use a ton of other languages. Go and Rust came to mind because they're quite sort of contemporary. A lot of people are using them in production now. But yeah, if you want to say, okay, I want to write something super performant, I don't think Ruby's going to be quite right because of the overhead of the runtime, so I'm going to use Rust, for instance, because Rust is nice and low level and nice and fast, but also designed in a way that it's quite difficult to hurt yourself. So if you want to do that with Rust, when you build your Rust binary, you can build it as a shared library, and then it will behave just the way a shared library would do if it was written in C. As long as you know the name of the function inside that library that you want to call, then you can just dial into it, and you don't even need to care that it's written in Rust. You just interface with it using the types that your machine supports.
And can you define seg faults for people out there that might not know?
Yeah, sure. So in C land, if you start playing around with how your memory is allocated, you have to make sure everything is aligned and clean. And if you make a mistake and you read to some memory that you're not supposed to, or you write to some memory that you're not supposed to, something gets corrupted, and basically the operating system says, okay, no more soup for you. You've got to stop running, and that's the end. So that would be a segmentation fault. That means you've done something that's broken the way that your program behaves in memory. The operating system has to step in and yank it out. And we're not used to this kind of thing in the Ruby world, I guess, because Ruby is really nice at protecting you from all of this. In the blog post that I wrote on this, I compared Ruby and C to being like kind of like staying in a hotel versus staying in like self-catering accommodation. So in a hotel, if you want to eat, you pick up the phone, ring room service, food gets prepared and brought to you. You don't have to care about how it's made. And then when you finished it, eventually someone's going to come along and clean that up for you. If it's self-catering, if you don't make the food yourself, then you don't eat. And if you don't clean up, then you're stuck in a mess. So that's kind of the difference. The difference between the two. I want to say cultures, but sort of the expectations that you have as a programmer when you're writing code.
So how is it like deploying this to production? Because if you're using H3, then do they provide binaries that you can just deploy to your instance that you're going to be running? Or do you have to compile it yourself and then ship that off? Or do you compile it on the server once it gets deployed?
That's a great question. What we decided to do when we wrote our gem is we wanted to use FFI to talk to H3 and get the nice DSL and the nice sort of memory management stuff for free. But actually, Uber don't provide binaries. They might in the future. It's just, it must be something that's never been necessary for them to do. So if you do want to use the H3 library, then yeah, you have to build it from source. And you have to build it from source on whatever machine you happen to be running on. Now, I've focused sort of on the benefits of FFI over native extensions. But what we ended up doing with our H3 gem was that we included the source code from the H3 GitHub repository as a GitHub module, as a sort of a sub-module of our project. We put that up to whatever version level we want to be in parity with. And then we use the native extensions functionality of the gem spec to actually run the make file for that code itself. So when you install our gem, it has to build the H3 source for you. And then once it's built, we know where it lives, we know where it is on disk, and we just we connect to it via FFI, and it's a really sort of simple process to communicate with it. But yeah, you kind of have to do it that way because you don't necessarily know what machine or operating system it's going to be running on.
Yeah, absolutely. And so if you've ever done a Rails new on a new application and done a bundle install or something, then you would see the gems installing. And every now and then you'll see a gem like Nokogiri that is going to say something like with native extensions. And it's actually compiling some C code or some other code so it can be used on that machine by Ruby. So is that how your gem is working as well, or how you guys implemented the H3, where it is just part of the bundle process, or is it a separate instance that you guys are having to do, or separate step?
No, it'll happen during the gem installation. So when bundler runs gem install, it'll get kicked off as a native extension installation. We would rather not do it that way, but since there isn't actually a binary available, you can't just do like brew install H3. It kind of felt like a reasonable compromise, let's say. But yeah, I think long term, if it becomes available as a package, then we'll probably just make it an expectation that it's pre-installed on the machine before the gem gets installed, and then it would be just like Nokogiri. If you don't have the right XML libraries installed on your system, then it's not going to compile either.
Yeah, and so I know for anyone who has installed Nokogiri before or updated it, it takes a while. That's probably like the longest gem it takes to install. What's your experience with...
I'm the most prone to breaking.
Yeah. What's your experience with the H3 compiling? Is that something where it takes a long time as well, or is it pretty quick and Nokogiri is just kind of one of those oddballs?
I'm not sure if Aaron would like you calling Nokogiri an oddball, but...
Speed to install in comparison to other...
Sure. I know, I'm only joking. So... I think H3 is actually pretty quick. So behind the scenes, it actually uses CMake. So CMake builds like a more complicated make file, and then it runs make for real. And then actually, it doesn't even need to do make install. So most C processors, after you've compiled everything down to a binary, you have an install step, and that'll put it in some library directory that's available across the system. So for us, we didn't even do that. We just build it so that it actually gets built in the directory to which the H3 gem is installed by Ruby gems. And then it will live in there as a shared object. Actually, that kind of has a nice benefit in that if you have a version of H3 installed already, that it's the wrong version, then when the gem installs itself, it has a version that it knows it's compatible with because we upgrade it lockstep with the way that H3 is released. But yeah, it's pretty quick, to be honest, and I haven't seen it break because it's like a pure C library. I don't think it has any expectations of what's installed on the system already. It's just basically a bunch of mathematics for how you deal with 3D space.
Yeah. And to install the native extension, did you have to make sure that you had something like GCC installed on the host machine, or is that all included and wrapped into FFI?
No, that's not included. So the FFI gem itself, you need the FFI gem as a dependency if you're going to write a Ruby wrapper that uses it. Now, I checked the GitHub stats, and I think there's about 750,000 projects that rely on FFI as a dependency. But when you install the FFI gem, it has its own native extensions, and it needs those because it's binding into libFFI itself. So you need to have a compiler on your system. So on a Mac, you'd have to have whatever the build tools are that come with OS X these days. In fact, it's not even OS X now, is it? It's macOS. That's my age giving away. So you'd have to have some compiler. It wouldn't need to be GCC necessarily. It could be like Clang or something. But yeah, as long as there is something that knows how to compile C, then you can build your native extensions.
And so likewise, that would go for anything like Go or Rust. You would have to have those specific compilers on your host machine in order to make use of a Go extension in Ruby or a Rust extension.
Well, if you did it that way, you could, but using FFI, you can make the assumption that it's already going to be there and has been compiled somewhere at some point. So you could package up your shared binary in some binary installer and have it installed outside of the bundle install process. I suppose you could still set it up so that if you're using a native extension, it sort of shelled out to the Rust compiler or the Go compiler. And that would be a valid way to do it. But yeah, the nice thing about using FFI instead of having a native extension is that you wouldn't even need to do that. As long as it had been compiled and installed at some point, then you could just say, okay, I expect this shared object to be present in whatever the shared directory is for libraries. And if it found it there, then it would run against it.
So kind of to shift gears a little bit, in your Medium article, I thought one of the most interesting things was when you were discussing hexagons and why Uber uses H3 and how they use it and the Teslization stuff. There's also a quote in here that said, hexagons are an important choice because people in a city are often in motion, and hexagons minimize the quantization error introduced when users move through a city. It looks like the link to the quantization error is broken. So if you can you tell us what that is?
I'd love to be able to, but that's kind of one step beyond my knowledge. It's to do with accuracy. So Uber tried using like a typical grid because there are only 3 different types of shape that you can use to break up space and tessellate evenly when you're trying to deal with something that ultimately is spherical like the Earth. So you can tessellate triangles, you can tessellate squares. Sorry, when I say triangles, I mean equilateral triangles. And then hexagons as well. So they all tessellate uniformly. If you use squares, then if you monitor how demand is shifting and moving through space, then you end up kind of with what effectively works out as rounding errors. But you don't get that with hexagons. And the reason you don't get that with hexagons is when you tessellate hexagons, the center of each hexagon is the same distance away for all of its neighbors. And you don't get that with triangles or with squares. So with squares, if you have one square and you surround it with 8 other squares, the center of the squares above, below, left, and right of that square are fixed distance. But the diagonal squares, the centers of them are at a slightly different distance. So you get kind of like a distortion because things aren't the same distances away. With triangles, it's even worse. I think there are like 3 different distances things can be. So you have to start sort of fudging the mathematics in terms of how far away you consider things to be from each other. But if you took hexagons and then each time an event happened within that hexagon, you assumed it was at the center, it was just sort of a way of approximating it. They call that bucketing. Then as things move from hexagon to hexagon, you don't get that same error because you know the center is going to be the same. So the maths behind the scenes ends up being way easier, essentially. I'm sorry, that probably doesn't fully answer the question, but that's the best knowledge I have on it.
No, that's really interesting. I mean, because I use Uber a lot, especially when I was in college. And one thing I would notice is that they spike during certain times, and I one time had a very large estimate for my ride. So I walked several blocks into a different area, and then did it again, and it was like $50 cheaper. Wow. So it's pretty interesting how they do that. So reading this article was really interesting.
Yeah, no, it's super clever. It allows you to do other sort of things like predicting movement and sort of coming up with trends and patterns and all of this on our side at Stuart because we're an on-demand delivery service. People request deliveries and they sort of expect whatever they've requested to be delivered within the hour or less. So we tend to get a lot of peak times around meal times because a lot of our services are used by restaurants. So in the UK, we partner with Just Eat, so we get a lot of deliveries through that. And we have a data science team that needs to keep track of how supply and demand is varying. And it's not necessarily just something that you could apply to pricing, but just understanding how things are changing over time in a city and how the demand shifts. And you can sort of notice patterns off the back of that and change what you're doing in response to it.
Yeah, it's crazy. When you think of something like Uber, you think, oh, some kid just made a ride-sharing app and, put it online. But then you read these technical articles, and it's like, holy crap, there's some really smart people behind there doing that stuff.
Yeah, no, it's amazing, actually. I didn't really know much about this before I got started because I'm on the back-end team rather than data science. So it was kind of like a learning experience for me. But the mathematics is quite well understood, actually. I think it's just it's not well understood in like general public or necessarily across the wider developer community. But yeah, there are like papers going back many decades on hexagons as a way of describing 3D space. And one thing I found really useful and really interesting when I was researching it was if you look at the way bees work, when bees produce honeycombs are hexagonal. And it turns out that is like the optimum way to distribute your wax and to store your honey. And in terms of like exertion and resources, bees have kind of self-optimized the way they build their honeycombs by settling on the hexagon. Now, I guess they didn't do any maths to figure that out, but it seems to work really well for them. So I thought, well, okay, there's clearly something profound, like a law of nature going on that says that hexagons are useful in some way that other shapes aren't.
Yeah. So what I'm hearing is that bees are a lot smarter than me.
It's crazy how many things exist in nature, and we spend all this time, trying to figure it out, but nature's figured it out long, long before us. This is just one good example.
Yeah, totally. It totally blew my mind when I found that out. Nature's awesome.
Yeah, because, when you go to Google Maps or something, and right before the map loads up, you see just a grid, a square style grid. So you would never think that, like, oh, they're doing something other than that. And I know this isn't the same scenario where we're calculating, herds of people per se. But for me, I never would have thought past that, like, oh, why don't they just put hexagons in there, just make it look a little bit different, like they knew what they were doing.
Yeah, it would look pretty. It'd look pretty cool if they did. I'd like to see if somebody's come up with like an alternative that does that.
So for the H3 library that you guys found, did that solve your exact need, or were you guys looking at alternatives and then eventually settled on the H3 library doing the extensions? Or was there a possibility of you guys implementing it in Ruby? So why did you go with the H3 extension route opposed to just writing the information yourself or the calculations yourself?
Well, that's a good question. From our perspective, Uber have a really awesome development team. They've got some really smart people working for them, and the open source projects that they put out are really, really high quality. So in terms of the fact that they'd built this system themselves and that it was in use, there are several tools that use it. So it's, sort of production tested. It made sense for us to start using it too, because we were solving similar sorts of problems because we're in a similar sort of problem domain. So like, it's not just ride, like getting a cab from one place to another. It's sort of saying, okay, I have a thing here and it needs to be here. And it doesn't really matter what it is. So we're kind of in the same business as them anyway. So it's like, yeah, okay, this is going to be perfect for a lot of the issues that we face. Now, in terms of whether it's the correct choice for us, we're still kind of building code around this. And building a Ruby binding was just sort of like part of the bare minimum stuff that we needed to get ready. So we don't just use Ruby, we also use Python and Scala and several other languages, and there are actually bindings available for H3 for all of these. It was just Ruby that was missing. So we kind of filled in that missing part, and now we're building out systems behind the scenes that actually use H3 for referencing 3D space. So that's not quite in production yet, but we're really quite optimistic in terms of the abilities that it will give us, because it's already sort of battle tested and proven that it works for companies like Uber.
So did it add to any technical debt in your application? Or maybe technical debt's not the right word, but did it add any complexity to its architecture? Or did it just pretty much seamlessly fit in?
I don't think it's added any more complexity per se, no. The only real thing about H3 that I guess sort of leaks domain-specific knowledge out is this concept of an H3 index. So if you want to reference a point on Earth, usually you'd use like a latitude and a longitude. And this is a really old way of measuring where you are on Earth. I think it dates back to either the 17 or the 1800s. So you have this idea of, degrees, whether it's like longitude, so how far up you are on the Earth, and then longitude, so how far round you are. So that sort of coordinates section, you can replace that with an H3 index. So if I say I want to calculate the H3 index that matches longitude, latitude, and it's to a certain resolution, then I can find the hexagon that covers my house. And then if I want to reference that later on, then I have this H3 index, and it's a unique long integer. So it's every single part of the Earth can be referenced with one of, I think it's like 300 trillion H3 indexes. So that's like down to less than the meter square level, square sort of resolution, I think. So that's kind of the only thing that leaks out, in that your application, as well as thinking about addressing places with, like street addresses and postcodes and latitude and longitude, it now also needs to care about having an H3 index. But that's basically it, really. I mean, everything else that the library provides, it's about sort of coping with calculations that tell you things in relation to those H3 indexes. So like, how far away is this H3 index from that H3 index, and what are the immediate neighbors for this H3 index, and stuff like that. So yeah, in terms of that, I think that's all it is. It's just H3 indexes need to become part of your vocabulary, and then everything else pretty much continues as normal. So I think really all it's been for us is like an extra column in a table.
That's pretty awesome. Yeah, I remember doing distances on a globe. So you have your two sets of latitude and longitudes, and then finding the distance isn't as simple as just calculating the distance between those two sets of numbers. There's a formula called the Haversine formula, which calculates distances on a globe or on a sphere, and the Earth being relatively globe-like-ish, then it's going to, be able to make those kind of calculations. But what it does not take into account for is elevation. So if you have two different points on the sphere, the Haversine formula is really just going to assume it's a flat sphere, and pretty much perfect. So it's not going to be able to very accurately determine the direct lineal distance between the 2 points. Do you have that same kind of issue with H3?
In terms of if things are at different altitudes, let's say.
Mm-hmm. Yeah.
I guess you'd have to, because the assumption ultimately is that once you get down to the hexagon level, it's considered flat. So when you get up to like the greatest level of resolution in H3, so this is like as high up as it goes, it divides the Earth into 110 hexagons, and then it needs 12 pentagons to make it all tessellate. So if you think about how a soccer ball is stitched together out of leather, it's like the same sort of thing. So the assumption is that once you split the Earth into those 110 hexagons and 12 pentagons, if you take one of those 110 hexagons at the highest level, it's assumed to be a flat space. And then recursively, you can break each hexagon down further and further. And again, it's assumed to be a flat space. So yeah, in terms of altitude changing, it's something that I don't think it would be able to take into account unless you started to do 3D modeling of the Earth, and okay, at this index there's actually a mountain, so that's going to change your calculations a little bit. But the usage scenarios for H3 tend to be in cities, and cities tend to be fairly flat. With some what you would consider small hills, I guess, but not that they would vary so much that it would sort of thwart your calculations. But yeah, I'd imagine there's a little bit of margin for error because, there's no way to model this if you don't assume that each recursive hexagon is a flat sort of plane.
Yeah. So is it more accurate than doing the standard, distance between 2 points with 2 latitude and longitude points?
I don't actually know, to be perfectly honest with you.
Okay.
I don't think it matters too much because the real reason that it was conceived this way is to be able to model the change of demand and supply over a relatively small area over time. So in some of the links on the blog posts, Uber have got some really nice graphics, and they show sort of like a view of San Francisco and how demand is changing, and you've got like dark hexagons representing high demand and then light ones representing low demand. So I think in terms of measuring how people are moving from one hexagon to another hexagon, it's not so much about measuring distance in that case. It's about sort of monitoring general flow of people from one area to another.
Yeah. Sorry for the 100 questions around there. It's a space that I've actually worked in the past and, is of a lot of interest in me because I've always just done the geo coordinates to calculate distances. And like I said, the Uber guys are a lot smarter than me, as well as the bees. And I didn't even think to use a hexagon. So
there's some great videos. There's a conference talk from one of Uber's engineers where they go into some depth about how it all works and why it all works and how they put it together. So yeah, it's really fun viewing. Personally, I've always liked maps. I love maps. I have tons of maps in my house. I have maps up on the wall. I've always enjoyed sort of seeing how things look like from above. And it's kind of sparked like an interest in learning a little bit more about geospatial stuff and how all of this stuff works.
So if we are, and I'm going to apologize for this, but if we are talking about the H3 on a globe, does that debunk Flat Earth Society?
Controversy alert.
I don't know. Do the Flat Earth guys believe in bees? Do they think bees exist? Bees don't exist, do they? It's a hoax.
I'm sorry for that. I'll apologize. I was recently watching a documentary on, what is it called? It's on Netflix right now. And it's pretty wild. Shoot, I'll come back to you and say what it was.
Is it related to the Flat Earthers?
Behind the Curve. Yes, it's on Netflix right now, at least in the US. And it's a pretty entertaining documentary.
Okay, I'll check that out. I guess if it's a Netflix original, then I should have access to it here in the UK.
It's a good choice of descriptive word, Dave. Pretty interesting.
Yeah. So is there anything else that you want to cover around FFIs and extensions?
We've covered a reasonable amount of it. I'd like to talk a little bit more about two things. So first of all, a little bit more about libFFI itself and what it actually is and does. And then I want to get on to something else that I discovered in the Ruby standard library that surprised me because I hadn't come across it before. So the really cool thing about FFI is it kind of puts you in a position where you can deal with, I'm going to use the computer science terminology here, you can deal with the primitive of a subroutine. So in Ruby, if we're going to call something in a compiled library somewhere else, you can regard that as a subroutine. So when you call a subroutine from an operating system, a processor has to stop what it's doing, sort of save its state somewhere else. Then you have to load your new subroutine. So you have to have an address in memory where it currently lives. You have to specify how it gets past its arguments. So are these arguments on the stack? Are they on the heap? Are they in CPU registers? And then once it's finished doing its thing, you have to handle how it returns its return value and how it hands execution back to whatever piece of code was running before. because something was running before and it was interrupted when we called this subroutine. And then also you have to consider like what variables were in scope. So like the closure of that subroutine, what things it had access to. And this is really complicated, and it's also really very machine specific. So depending on the machine that you're on and the operating system that you're on, there are several different ways that all of this could be done. So when libFFI was written, it put all of this stuff together. These things are called calling conventions. So the conventions for how you actually call a subroutine, how it works, and then what happens afterwards. So libFFI is really cool because for each architecture that's in general use, they filled out how all those calling conventions work in their C library. They also made it work for each commonly used operating system. And they basically gave you a toolkit where you could write your own language-specific bindings on top of this. And then for free, it would just work on all of these different architectures and all of these different operating systems. So I found that super interesting. I've spent quite a lot of time the last few weeks just figuring out how subroutines actually execute. And actually, I think that might be my pick later on. I found a really awesome tool that sort of shows you graphically how all that works. So that was the first thing. That was what libFFI is. And then the second thing I wanted to go over was, have either of you guys heard of something in Ruby called Fiddle?
It sounds familiar, but I feel like I may have read about it, but that would be it.
I think we had someone talking about that last year or something. I can't remember though. I have not dove into it.
Okay. Well, I sort of happened upon it by accident because I was just sort of trawling the internet for articles on bindings in Ruby and sort of different approaches and pros and cons and sort of general research. And what I found is that typically people will write bindings for C Ruby using native extensions, or they will use the FFI gem, as we decided to do. But then I also found that if you look in the Ruby standard library, there's actually a module called Fiddle. And Fiddle is libFFI wrapper for Ruby. So functionally, it's doing the same thing as the FFI gem. Now, the FFI gem was actually written, I think, 10 or 12 years ago. And there's a bunch of conference talks explaining how it works and when it was originally released. But the addition of this Fiddle module to the Ruby standard library actually happened in Ruby 2.0. And that's quite a long time ago. I think that's like 7 or 8 years ago at least. And personally, I know the Ruby standard library reasonably well. I hadn't come across this at all. It's like a sort of a buried treasure in the standard library. So you can do all of this kind of FFI magic yourself without even needing to include the FFI gem. You can just do it natively in Ruby. The syntax is a little bit different, but ultimately it fulfills exactly the same role. As long as you know the name of the method, the name of the function in the compiled binary that you're accessing, then the Fiddle API lets you access it in exactly the same way. And you actually similarly provide it with a list of argument types and return types, and it just works. So I thought that was a really fun find. I'd encourage you guys to check out the documentation just to see what it looks like.
Yeah. So quick question around Fiddle. And I don't know if you know this answer, but if you are using Fiddle within a gem to then mount in a C extension or, a C module, is it going to go through the same process as FFI? So when you do a bundle install, you'll get that with native extensions and it'll just kind of work automatically? Or is this assuming that you already have that binary or that module already compiled in there on the system?
Well, actually, it comes with Ruby. So when you install any version of Ruby later than 2.0, the libFFI module is, I guess it's included as a dependency there because it just sort of works out of the box. You don't need to compile anything. You can just open your editor and write some Ruby and just refer to Fiddle and it should just work. Maybe don't quote me on it, but I'm pretty sure it comes for free when you install Ruby.
Yeah, I meant more of the extension that you're going to be using, like the H3 library. Is Fiddle going to assume that the H3 library is already compiled and ready to go, or will it do that as well?
I'm sorry, I misunderstood your question. Sure. So
no problem.
The interface for Fiddle is very similar to FFI. So you start by saying, okay, FFI, here's a library, and either you can give it like an absolute path and say this is where it is on disk, or you can give it the name and it's going to go ahead and search in the usual directories on a system. So like user local lib or something along those lines. So yeah, essentially Fiddle will do the same thing. You have to tell it what library you want, and it's going to make the assumption that it's already been installed.
Cool. Was there anything else we should talk about, or should we move on?
I think that's all I've got.
Awesome.
So yeah, whatever you guys want to talk about next.
Yeah, well, Sean, if people want to find out what you're working on or stalk you online, where would they go?
That's a great question. So a few places, it turns out. You can follow me on Twitter. So I'm at code_Sean. So that's SEAN. I'm also on GitHub. So github.com/Sean Handley. And I do quite a lot of blogging on Medium. So if you're on Medium, my username is @Sean.Handley. So I do some of the stuff under my own name, but we also have a publication at Stewart. So it's like a company blog. And I put quite a lot of my technical articles in there as well.
This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume. You spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/rogues. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
Cool. Should we move on to picks? Andrew, do you want to kick us off with picks?
Sure. So I don't know about y'all, but I have to format a lot of date strings in Ruby, and every single time I have to go consult the documentation and figure out, do I want %B or lower b? And I have to do that every single time. So I found a tool. It's called strftimer.com. And this is everything I've been looking for my entire life. You basically just put in the date format you want, and it'll give you what the strf time should be. And so that's been saving me a bunch of time recently.
Nice.
Awesome.
Yeah, on the spirit of strf times, I'm going to pick my favorite one just so you have another resource there. It's foragoodstrftime.com. So, the strftime.com. And I like it because it kind of gives you a little GUI where you can visually see the date that you want, the format. You just click on it, and then it gives you what the output string should be. So that's one of my favorite ones. I don't think I have any other picks. So, great. And then, Sean, what are your picks?
Sure. So since we've been talking about sort of lower level machine details, someone on GitHub put together this amazing interactive browser tool. So I've shared the link, and I guess the link will be part of like the podcast release. But it's called Mini C hosting. So it's like a visualization of a machine at runtime. So on one side, you can dump in some C code. You can hit compile. It will kind of turn it into some assembler for you, so you have an idea of what the assembler would look like. And then it gives you like a raw picture of what's going on in memory, and you can step through it like step by step, and it even has a little tutorial to explain to you more about how machines work. So I found this super useful in learning more about low-level details when the program gets executed.
Awesome. And now I actually remember the pick that I had before, and it's a big one, so I don't know how I forgot it. Strf timing got me distracted. It's Kubernetes. So I've been spending a lot of time with Kubernetes lately on my home servers. And one of the things that I've found is that it's not easy to set up, and it's not easy to support. It actually adds a huge complexity to your architecture and to your infrastructure. But with the Kubernetes engine that I've been using, Micro K8s, it's actually been really enjoyable. It's a single node supported, so you don't have to have multiple servers like you do with a traditional Kubernetes setup. So for a home and sandbox environment, it actually works out really well. And then also, it doesn't rely on virtual machine, KVM, or anything like that. It just kind of all handles it natively for you with Docker containers and stuff.
Awesome.
All right. Well, Sean, thanks a lot for coming on and talking with us and educating us on hexagons today.
It's been a pleasure. Thank you guys for having me.
Right.
Of course.
Bye.
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 Bandwidth for this segment is provided by Cachefly, the world's fastest CDN. Deliver your content fast with Cachefly. Visit cachefly.com to learn more.